All right, everybody, three things we want to get through in this video. We want to talk about Makefiles. We're going to walk through a server.cpp, and then we want to talk about tmux. How do we keep our servers running, even though we're going to close out of these windows? Let's talk about Makefiles first. Makefiles are great. When I type make, it's going to automatically compile stuff for me. I don't ever have to type the compile line other than to put it in a Makefile. So let's go ahead and open up this Makefile. Capital M Makefile is the basic one. There are lots of versions of makes out there. We're going to use this basic one. First thing that's going to happen when you type make is it's going to try to make this binary called all. All doesn't exist ever. That's by design. And that is dependent upon two binaries called get and get2. So it will then try to compile get and get2. To compile get, it needs a source file called get.cpp. And then it'll look at that, find that. And if it's newer, if get.cpp is newer than get, then it will run this line. So we're going to add one for our server. So we need an executable called server. That server is going to be dependent upon a server.cpp. In order to compile that, I need to g++ server.cpp-o server. Now, there's a tab here. You saw it show up. It has to be a tab. It can't be spaces. And so this adds this server executable to my list of all things that I want to compile. So I'm going to save this and close it. Now, if I type make, what it's going to do is compile the server. You can see that there. If I type make again, it says there's nothing to be done because server is already compiled and newest and up to date. Let's go ahead and look at the server.ppp file now and see what's new inside this thing here. This is a little bit different than what existed in the repo a few weeks ago. So go ahead and grab yourself a new copy. What I've done is I've made it so that when you run the server, it expects a port number on this particular version. So I grab that port number from the first argument, and then I convert it into an integer using a2i like we did in the client. The first thing that happens is we set up all of the address and structures for the socket like we did last time. So we have this socket file descriptor S, which is an internet sock stream socket. Basically, this is just, hey, I want a TCP socket. And I don't have to specify an Ethernet address here. I'm going to say any, which means I just want one that's on the server. But I am going to specify the port number. So once this is done, I've got all this set up for a socket that's going to be connected to the Ethernet address of this particular system, the system 470, on whatever port I specify here, if I have the rights to do it. So how do I actually do that? Well, bind is what you're going to use to say, hey, operating system, I have this socket address structure. Can you give me the socket that would be created by that? And, you know, the server will either say yes or no. If it says yes, then this S becomes the socket on this port that you specify. So let's say you specify port 23,000 like this, okay? So it says printf binding, and then if successful, we won't get this P error here, and instead we'll get this listening here, so you can see that here. So after we have been given permissions by the OS to use this socket S, what we need to do is listen for incoming connections. And if you watched the TCP video, you saw listen in the state diagram. That's what we're doing here. When a connection comes in, it will go through listen, and then it is our job to accept that connection and to handle that client. We're only going to handle one client at a time, so our backlog is only one here. Basically, if somebody tries to connect to this server, it will kind of hang for them because I'm not going to deal with them at the moment. So that's fine. So I get an incoming connection. I handle it right away, and I enter this while loop, which accepts that incoming connection. So what happens here is that I get a client socket descriptor instead of the server's socket descriptor. The client has a different IP address and port number that's coming in. So this socket that I'm getting from the client is a little bit different than the socket that I'm listening on. And if I want to send and receive with the client, then I have to use this socket descriptor and not S. S is for my incoming stuff. And so this CSD is my specific connection to the actual client that's connecting to me. If you would like to see some information about that, you can uncomment this line here and it will tell you the IP address of the connecting client and everything. I'm only going to print out the port number here so as not to expose an IP address. What this server specifically does, let's scroll down quite a bit. What it does is it sets up a message and immediately sends it. So when somebody makes a connection to this server, the server immediately responds with hello client, like this, right? That's what this send is right here. It's send over this socket descriptor, this message has this length with no flags. And then what I do is I wait for the client to send me something back. So the server is doing a receive. So I make my buffer, I zero it out, I do a receive on the client's socket descriptor, this particular buffer, 127, not 128, leaving room for that null character. And then I output whatever I get back. Now, in your homework or something, you might want to do something based on what you receive, right? When the server receives the words REQ in your homework, you responded to that in some way. So your server's probably going to respond in some way, but my server's not. What my server does right here is it shuts down this client's socket and then closes it. So basically it's like, I quit, I'm out. And then it goes back up to the top of this while loop where it then waits to accept yet another incoming connection. So let's look at this in practice, okay? So I've run the server here. I'm gonna jump over to my machine, okay? How can I make this work? I think, well, I can put it up here, right? I'm gonna jump over to my machine. And what I'm gonna do is I'm gonna telnet to 470 on this port. Now, telnet is the dumb way to make a TCP connection. That did not work for our client server programs last time because of our specifications of our application layer protocol, and it won't work for this one either, but it does work for this server.cpp. What you'll see is as soon as I connect up, I get this message from the server. It just shows up, right? The server immediately sent it, and it says here, I sent this message. And the server is now waiting for a response. So I'll say, hi back, server, and I'll hit enter. And you can see that I received 16 bytes. You count these up in between the quotes here, and you'll get a number like 15. Well, it turns out this return counts as something, right? So there's a return here. If you want to try that again, I'll make another connection. I'll just type hi. I got 4 bytes back. That's curious. I just said maybe there was a return here. This might be sending a form feed and a return /r/n. Anyway, doesn't matter. We won't be dealing with those in our protocols. But it is interesting that telnet can be used to kind of test your client and make sure your client is alive and stuff like that. Okay, now, if I were to close this window, this server would close along with it due to hangups and cascading parental death of children processes and things like that, right? So what I want to do is set up a way that I can keep this server running forever. And the way that I'm going to do that is with a program called tmux. So I'm going to hop back out of Tsunami here, my home machine, and I'm going to jump back over here to the server, and we're going to talk about tmux. So tmux is something that doesn't respond to hangups. You can do a tmux ls, and that will show you all of the tmux windows that you have created and sitting around waiting for you. To make a new one, you type tmux new, and then you can give it a name with -s. So maybe I'll call this u2. You can see there's a u up there already. So this made a new tmux window. You can see it kind of looks like an Emacs window or something. But I still have a shell up here. And in this shell, you can do whatever you want. So in this case, I'm going to run a server, say 23,003. And you can see it's binding and listening. Now, to leave tmux, you hit Control B and then the letter D, but not Control D. So it's Control B, let go of everything, and then just hit D, right? Only one hand. So that detaches from that. But I can exit this now, and the tmux will live. So I can reattach to it with tmux attach -tu2. You can see my server sitting there on 23,003 just fine. I can also attach to U. You can see this is a server on port 23,001 sitting here. And this will persist beyond your connection and everything. So tmux is how you're going to leave your servers up. When you all get your homeworks, you're all going to have servers and port numbers that are distinct from each other and have room around them so that you can fail a little bit. For example, when you put a server up, if you take it down immediately and then try to put one back up after a connection has been made, what you'll notice is that you'll get this binding error address already in use. And if you paid close attention to that TCP video, you learned that there was like this 2-minute wait out here. Now, I have to hold this port in reserve for at least 2 minutes to make sure there aren't any old packets destined for this old socket. And so it's going to take a couple minutes for this to close down. And so instead, what I'll do is I'll give you all a couple of different port numbers so that you can use those for testing. 23,001 is locked down because that's in a tmux over here. 23,002 is open. And I can try to connect to that. There we go. But if I immediately try to do that again, right, it's in use. But hey, it's been a couple minutes. Maybe 23,000 is back. Not yet. All right, so I don't want to extend this video just so you can see that 23,000 will come back. It will, but we'll stop it right there. As always, take care of yourselves and take care of each other. See you all next time. Bye.